All right, recording now. So I'm Lima Platoon guessing game. I'm going to fork this over to my GitHub account. Forking, it's making a copy. Great. All right, there it is. I'm on Tom Preet, forked from Lima Platoon. I'm going to click the green Git clone or the clone. Come on here. I'm in Lima challenges. Here are all the challenges I've been working on. I'm going to Git clone. And then we have the guessing game right here. Open that up. Close that out. Oh. And I'm going to CD into guessing game. I'm going to list everything out. I've got the guessing game, but I don't have a spec file. Let's just, well, before I create a spec file, let's walk through this, the README. So it said, build a guessing game, build a simple guessing game. This challenge will help you to break down problems into implementable pseudocode, implement basic Python class, and identify when to use instance variables, use control flow and iteration when appropriate, explain how instance variables and methods represent the characteristics and actions of an object. Cool. So here we're going to just create a simple guessing game. Let's create a simple guessing game. Cool. Your guessing game should be initialized. So it looks like here's like the requirements of the game. So I'm just going to copy this over. And just comment that out. So it says, here's like some examples of the minimum requirements for this guessing game to work. But I don't have a spec file. I want to do some TDD. So I'm going to create a spec file for this guessing game. So I'm going to do touch guessing game spec.py. Created a guessing game spec file. Here it is. I'm going to open that up in my current window, split the screen. Here we go. So now I want to write some unit tests for this guessing game, which is pretty straightforward. I can look down here for an example. Or I can say like, Call of Duty game. Actually, I'm going to do the guessing game part first, and then I'm going to write test specs because there's something I want to show you about the unit test library when we go ahead and write the unit tests. So in here, the first thing it says, your guessing game class should be initialized with an integer called something like answer or answer number. How do I initialize an integer with this specific variable? What do I have to call first?
The init method.
The init method. And def dunder, which is that double underscore, which we call dunder, init. Then I need to, the first argument that I always pass in to any instance methods are going to be self. Most of the time. We'll get to when it doesn't later on. Self. And then we're going to initialize it with an integer called something like answer number. What does the init method do? And when does it get actually called?
Whenever you instantiate the object.
Whenever I instantiate an object. What does that mean, instantiate an object?
Create an instance of the class.
Create an instance of the class. So I'm just going to print answer number. For right now, I want to print this answer number. How do I create an instance of this guessing game class? So I can say like, can someone tell me how do I create a new instance?
Guessing game, open close parentheses.
So
you don't have to, I mean, you could assign it.
So yeah, I'm going to assign it to a variable because I'm going to use this throughout, just like testing real quick. So I'm creating a new variable called new game. And in order to instantiate a new instance of this guessing game, I can call it guessing game. And then what, parentheses?
Yep.
Is that it?
No. Anything that's in the init, as far as parameters after self, also need to be assigned in when you call the function to initiate it. Unless there's like you can also set up default parameters. I don't think we've gotten to that part yet, but I know I've used them before. I'll set up defaults. But so any parameter after the self in the init needs to be passed along when you instantiate.
Correct. Any argument that I pass in after the self in the init also needs to be passed in when I'm instantiating this. Most often. We'll get to when it doesn't have to, but going forward we will. So I'm just going to run this to see what happens if I don't pass anything in. So I'm in guessing game. I'm going to Python guessinggame.py. It says traceback file guessing game line 13. So I'm coming down here, line 13 in module, new guessing game, type error, init missing one required conditional argument answer number. So it's missing this right here. So I'm going to just type in 40 and clear it. So I'm initializing it with an initial answer number, which is an integer. So I'm going to run Python guessing game again. Zoom in a little bit and run it. There we go, got 40. But now I need to see what it says. Initialize with an integer called something like, cool. Define an instance method. All right. So I've got this answer argument, but I'm not storing it anywhere. So I want to store it in what is called answer number equals. What is this self dot answer number? Why do I prepend self to it?
Makes it an attribute.
It's an instance variable.
It makes it an attribute. It's an instance variable. How is an instance variable different than a local variable?
It's only applicable to that particular case, and you're tying it to it with the self statement.
All right. So the the self answer number is only accessible through this specific instance of guessing game. So within this new game, guessing game. However, it's also the self.answer number is an instance variable. I can have access to this self.answer number variable throughout this entire class. So yeah, I can have access to this answer number variable throughout the entire class. I don't necessarily have to pass it in to other methods as a parameter or anything like that. So, great. So let's just look at define an instance method called guessingame. But before I move on to the guessing game method, if I wanted to access this answer number, how can I get it? How can I access the answer number in this new game instance?
New game dot answer number.
Yep, I can do print new game dot answer number, and it should print whatever this argument I passed in. So I can access it that way. Cool.
If you're calling it for something else, you could also use a get method, but that's a different thing, all right?
I'm sorry? There's like a
If you're
get
using
method.
it in a different aspect, you can also use a get method, right?
I don't know. I've never used the get method before. I think I have maybe once, but I don't remember what it does. All right, so we've initialized with an
There's no private variables in Python, so that sort of obviates the need for getters and setters. Though you could write them, but you can still access the private variables. But that's the whole convention of using an underscore to let everybody know, hey, don't mess with this.
Yeah, under the hood, that's what Python does. It has a get attribute method under the hood that when you do the dot syntax, it runs under the hood. It runs that get basically what looks like a getter to grab it for you.
All right, let's move on. So define an instance method called GuessingGame guess. Generally means, so hashtags and documentation generally means it's a method. In our case, GuessingGame has a method called guess, which takes in an integer called user guess as its input. Guess should also return the string high if the user guess is larger than the answer, correct if the user guess is equal to the answer, and low if the user guess is lower than the answer. So I need to define a method called guess. So I can do def guess. What's the first parameter that I need to pass in to guess this guess method?
Self.
Self. Why do I need to pass in self?
In order for it to have access to answer the Init, I would guess, right? And any of the class variables?
Correct. 100% correct. Yep. The reason why we pass this self in is because we want to give this guess method access to all the other methods, instance variables, instance methods and instance variables throughout the class. So that's why self is always passed in first. We want to pass in, is it user guess? They want me to use, which takes an integer called user guess as its input. Great. And then here it says, guess should return is larger than the answer. Correct if the user should have. And low if the user guess is lower than the answer. So the pseudocode's already kind of written out. Whoop. So return a string if user guess is larger than. Now, how do I access the self.answer? How do I access this answer number variable within this guess method? What should I write right here?
Self dot
Answer number. So if it's higher, I can say return high. Else, elif, if user guess equals self.answer number, return correct. If it's not that, we can do else return. So I'm going to move this up. Else return lower. Or return low, right? So I did all that correct if the answer is. So I kind of done all that right now. Then it also says define an instance method, GuessingGame solved, which returns true if the most recent user guess was correct and false otherwise. So I can define a new method called that's solved. I need to take in self because I want to have access to other instance variables and methods potentially throughout the class. Do I need to pass in anything other than the self? Are there any other arguments? I don't think so. It doesn't tell me I need to pass in anything. But now it says like I need to return true if user guess is if user guessed the correct number. Now, how can I do this? So it says, so I can actually instantiate another instance instance variable called self dot is solved, like, and assign it an initial value of as false. So I'm just gonna initially, I'm not gonna write any code right there. So we have print new game answer number. Let's run this guess and see if this works. So when I invoke an instance method, I need the parentheses, and I also need to pass in, I'm gonna get rid of this comments just to clean up the code a little bit. And I also need to pass in any parameters that I need, or any arguments that I have passed in the guess method. So my first guess is 20. And if I run this, what should I expect to see? If my user guess is 20.
Oh.
Low. If I do, I just want to make sure the logic is right. I'm going to do this 50 and 40. So clear. I've got low, high, correct. So first guess was 20. First guess was 50. Or second guess was 50. Third guess, I actually guessed the correct answer. Cool. So the guess logic, the guess instance method is working as expected for right now. Now, let's see if it's, so after I have it, so after I guessed it correctly, I can run that is solved, which is an instance variable, which I can access by just calling new game, which is an instance of guessing game, dot is solved. And even though I guessed the correct answer on line 27, let's see what is solved looks like.
I think it's just solved.
So we have the method is called solved.
Oh, you're right.
But I have an instance method called is solved, and it's currently set to false. So down here, I guess low first, guess high second, guess the correct number third, but my is solved is still false. So where can I change this is solved to true?
Line
15.
15.
In between line 14 and 15. So here, since I have this self and I have access to all the instance variables within this instance, I have access to the answer number and I have access to the is solved. I can change that self, can reassign it, is solved equals true. So I'm reassigning it is solved to be true. So now let's see what it looks like. So I got guess low first, guess high second, guess correct third, and what should this be equal now? True. Great. Now if I got rid of this guessing it correctly, I cleared it, it would still be false because I haven't answered it correctly. So now this instance method called solve should return, what should it return? Self dot is solved. Because we want to actually call a specific method to check whether it's been I've correctly guessed the right number. So I can actually get rid of this is solved and just print new game dot solved and invoke it. I don't need to pass in any parameters or any arguments because it doesn't have any arguments that I pass into here except for the self, which I don't need to actually pass in here. So I'm going to run this again. It should still be false. So right here it says false because it's coming in a new game. It's calling this solved instance method. Come up here, it's returning self.isSolved instance variable, which is currently false because I haven't correctly guessed the right answer. But now I'm guessing the correct answer at 40 on line 28. So let's run through this. I'm going to run the Python guessing game again. Therefore, it's true. Now it's true. Does anybody have any questions about the guessing game? It is best practice to not, when you're checking something like solved, it's best to write a method to check instead of accessing the instance variables directly. Like, it's better to do this. Better to do this instead of new game dot is solved. Even though they give you the same answer, but in the future, solve might have some additional logic in it at some point, depending on what type of game you're playing.
So if I understand correctly, the Pythonic way to mark that as private is is solved would have a leading underscore. Is that correct?
No, because we're still access. I'm sorry. On what line?
In your initialize it when you set it up in the class. If you,
If I do that?
Yeah.
No, because I'm still accessing this throughout the application or throughout the class on line 15. So I'm actually changing it. So I'm still accessing the is solved throughout the class instance. So we are using that variable.
Okay.
And let's go. So we have some. This is one way to test it, or we have something called driver code. So I'm going to import random up at the top. I'm going to get rid of that. Import random is a built-in library within Python that performs specific operations with regards to like random, like numbers and stuff. So I'm initializing a new guessing game instance, grabbing a random integer between 1 and was it 99? I've got this last guess variable. This is all outside. It's all outside of the class. Got last result. I've got a while game solved. So it's running this instance method while it equals solve. If this last guess variable does not equal none, so if it doesn't equal none, run, oops, your last guess was some string interpolation, F strings. Otherwise, so if it does equal none, it's going to jump down here. It's going to grab some user input, enter your guess, puts it to last guess, assigns my input to the last guess variable, which then assigns it, inputs that as an argument in the guess method as my user guess. And then it says last result. Cool. And then it says print last guess was correct. So let's run this and let's see if any of our code will work. Enter your guess. I'm gonna do 50. Oh shoot. What just happened? So file guessing game line 32 right here. So last result, guessing game last guess, guessing game line 10 and guess if user guess is greater than self.answer number, type error greater than not supported between instances of string and instances of integers. So that's interesting.
I think input returns a string.
Yeah,
You have to make it an int.
Thank you. Let's test that. I want to test the type of last guess. Can I print that? Just want to clear. This might run. Oops, your last guess was 50. Wasn't okay. So here it is, class string. So I have to turn that string into an integer. So anytime you input in the terminal in Python, it comes out as a string. So even though I typed in 40, it comes out as 40 as a string, or 50 as a string. So where do I want to change this input into a integer? I can do it here. By doing
Well,
that.
if you're going to really leverage your class, I would probably make a method, I guess, and call the method.
I can create a separate method. That's true. Yeah, let's do that.
Yeah, one of the other advantages of creating a separate method, for instance, called like get user input as the method name, you can throw in other logic in there because the game's looping. So if you have like 1,000 numbers to guess through and they don't want to sit there and they want to quit, you could throw in other options to quit based on their input.
Okay.
But that's, you know, extra stuff that you can throw in there, but it would be thrown in under the same class definition.
So I haven't done this before. I haven't created a new method. I've done it somewhere else, but let's create a new method. So we can do return int, what is it? Get user input. You can do that, but that might run into some issues. So we could take last guess, and then I'm just trying to think. We can do is it game dot convert will that work? I don't know if that will work. Try it. Oh, did I change something? Oh no, it worked, right? So 50.
Yeah, it's working until you put in a letter or something that can't be converted.
Right. So I think in the requirements it said initialized with an integer called something. So it should be initialized with an integer. So we can, I don't want to say we can safely assume that every time a user inputs, it will be an integer, but we can check for edge cases after this. So I just want to see your last guess was 50 was too high. So we can do 25 was too low. Was it 37 was too low? Was it 43? Too low. 47. Oh my gosh. Cool. Enter your guess was 45 was correct. and then the application exited. What if I run this again? Oh, and write like J. It's like, oh no, invalid literal for int with base 10. Yep. Run that again. If we put just like K, throws an error. Can I do a try except? Would that work?
That's how I did it. Yeah, try accept value error.
So a try except says try. Oh crap.
You want to put value error in your accept so you're not catching everything. You're just catching that specific thing.
Do I have to import anything? So
No,
what do
you
you
don't
think?
have to import.
What should I put here? Who was
After
saying?
the between the accept and the colon, put the identifier, the object type value error.
Like value error?
No parentheses, just like that.
Oh,
but
yeah, sorry.
yeah, there you go. So you're only catching that error specifically, which matches on the output on the bottom. Yeah, exactly. It matches that. So you're only catching that error. You're not catching all errors. So if something else goes wrong, you're not thinking everything's fine.
Input value should be an integer.
I penalize my player another stroke for that one.
I'm sorry?
So I penalize my player for an extra stroke for in the accept there for putting in a string.
Again, this function is overall supposed to be converting to an integer, and when we initially called it down at if
up
you
here.
scroll down, well, when we scroll, which line did we call it on? On this particular instance, this is getting passed into guess. So basically, we need this convert input to int to actually returns an integer of some form.
Yeah, because we pass it into here.
So if we try to, you could print out a message saying, "Hey, please input
but it's still gonna
positive integer," but you need to actually return an integer.
Right.
So I did basically what we're going to talk about later today for recursion, and I, basically in the accept block, I call the function again until it basically returns an integer.
You could do that or loop it, and yeah, it'll print the message, and you can just stick a while true, just have it looping indefinitely.
Yep. So kind of like here.
Yeah, there you go. Well,
but I mean, I'm still actually
processing it. Yeah.
Yeah.
What I would do, like the benefit of having your own separate input function is that it will force the user to input an integer, and it'll keep asking before it will return anything. So it will only ever return an integer.
Right. Yeah. So yeah, this would be considered like an edge case. This is good to be doing, but for like time's sake, we're gonna jump over to test specs. But yeah, so if you aren't familiar with try accepts, we're gonna cover them later on in the course. You'll see them. But yeah. So, but if you didn't do this specifically, that's totally okay. If you just converted it to an integer somewhere else, that's fine. This is like beyond the requirements of the challenge. So let's move over to specs. So for unit test, the first thing we have to do is actually import the unit test library. We have to import the GuessingGame class. So we haven't actually been testing classes yet in our unit test. So we can say like from GuessingGame import GuessingGame. And notice how it's kind of already, I'm doing import, it already knows, and then I'm typing and it already kind of knows what I'm going to be guessing. or can predict what method or class I'm going to be trying to import. So we can do class guessing game test case, which is inherits. We'll get into inheritance later on in the course. This test case class. And so I can test, I want to like test high, test low, test correct. What else can I test? And for each one of them, I can also test like test is solved. All right. So there's a couple ways I can do this. I can define each test, like case test returns high, and do like self. I'm just gonna do a pass. I just want to pass this stuff. First test returns low, self, pass. I'm gonna move this down here. And then def test returns correct. And then pass that. So I'm just going to copy over some code. When user guesses 20, it returns low. When user guesses 50, returns high. When user guesses 50, returns high. When your user guesses 20, and then when user guesses the correct answer, it returns correct. Now, how do in here, I can actually like set up a new game, like new game equals guessing game 50, and then run self.assert equals self.new game. Is it new game.guess 50 should return high.
That would be returning correct, because when you initialize your new game, you set the answer to be 50.
Thank you. So if I did 40, I do high. Then I can also do self.assert equals. I want to just run another test. Is it new game is solved, or is it just solved? Equals false. And I pretty much want to copy this down to here, but instead of 50, I want it to be 20, and have it say low. Game is solved is still false. In place of this, I can do self equals. I can do 40. It should return correct with true. But notice how in each and every test case, I'd have to set up a new game and do that and that. That's kind of like a lot of repeated code I have to do. It's not really a lot, but as my test cases increase, I don't want to repeat this new game every single time. I don't want to redeclare this new game variable or this instance of guessing game every single time in every single test case. So I'm gonna like Google unit test Python before each test. That's it. Before each test. So I just typed in, I literally just Googled before, and I'm looking down here. So it says the setup method and teardown method allows you to define instructions that will be executed before and after each test method. They're covered in more detailed. So I'm just going to click on that. The setup method called to prepare the test fixture. This is called immediately before calling the test method. So I can look at, where is it? So I'm gonna look up setup. I just want to see if there's any examples. So right here, I've got this test can be numerous and their setup can be repetitive. Luckily, we can factor outside setup code by implementing a method called setup, which the testing framework will automatically call for every single test we run. So it looks like we have a built-in method called setup, which will execute every time right before every single time each test is actually called. So I can do this. Instead of setup widget, I can do self, because again, this is a new class, new game, equals GuessingGame.40. And now I can delete the other times I've initialized a new game within the test. So this test method, or this setup method, will execute right before it runs each and every test. So it'll run the setup method, then run this one. This test returns high, and then I'll run this setup method again, and then I'll run this test returns low, and then I'll run this setup method again, and then I'll run this test returns correct. Let's see if that actually works. Shenanigans. I'm going to delete this driver code. You're going to be seeing driver code later on in the upcoming days and weeks. Driver code is usually in its own file, but for this challenge, it could be within the guessing game. So I've got this guessing game spec. Uh-oh, what happened?
You're forgetting you're done.
Thank you. Love forgetting that. So I got this, don't forget that part. So there, 3 tests ran. 1, 2, 3. 3 tests, all okay. I can green, guessing game spec. 3 tests ran in 129 milliseconds or whatever that is. Using 8 processes, okay, passes 3.
Hey Tom, I'm curious. Will green run it without that statement there? Because you should be able to run it without that statement.
Which one?
That line 31 to 32. If you remove it and then run green on it, will it still run it? I don't actually use green, so I don't know.
I have no idea. Oh wow. That's
yeah.
weird.
So and you can do the same thing, but you have to run it as a module. You have to say Python-m unit test and then the file name, and then it should. I think it will still run that for you if you don't have that statement there.
All right. Cool. There we go. Does anybody have any questions about the guessing game Class. Anything? We're going to do another review of OOP after Madi comes in. All right.